This number destroyed everything we thought we knew about reality. Okay, wait. Let me back up. Richard Feynman, the greatest physics explainer who ever lived, had this thing he did. He kept a list. 12 problems. Questions that obsessed him. Questions he couldn't stop thinking about. And one of those questions, just one simple question, led him to something so bizarre, so impossible, that it literally broke his brain. The question was this: why that speed? Not what is the speed of light. Everyone knows that. It's 299,792,458 meters per second. But why? Why that number? Why not faster? Why not slower? And here's what nobody tells you. The answer to this question will change everything you think you know about reality. Stay with me, because what you're about to learn, you can't unlearn. All right, let's talk about Feynman for a second. This guy wasn't normal, and I mean that in the best way possible. He worked on the atomic bomb during World War II, won a Nobel Prize for quantum electrodynamics, figured out why the Space Shuttle Challenger exploded. He played bongo drums. He learned to crack safes as a hobby. He painted. He learned Portuguese just for fun. But here's what made Feynman different from every other genius. He didn't just solve problems, he lived with them. He carried them around in his head like pets, constantly feeding them, constantly playing with them. And one of his favorite pets? The speed of light. Now, most physicists in the 1940s just accepted it. Light goes fast. 300,000 kilometers per second. Great, moving on. But Feynman couldn't let it go. He kept asking, but why that speed? And here's where it gets weird. Because the speed of light isn't random. It's connected to something else. A number. A pure number with no units. No meters, no seconds, nothing. Just 1/137. Feynman called this one of the greatest damn mysteries of physics. What does 1/137 have to do with light speed? Hold that thought, because before I answer that, we need to talk about what speed even means. Quick question. What's your speed right now? You're probably thinking 0. I'm sitting still watching a video. Wrong. You're moving at 1,670 kilometers per hour because Earth is spinning. You're moving at 107,000 kilometers per hour because Earth is orbiting the Sun. You're moving at 720,000 kilometers per hour because the solar system is orbiting the galaxy. And you're moving at 2.1 million kilometers per hour because the galaxy itself is moving through space. So which one is your real speed? The answer? All of them, and none of them. Because here's what Feynman realized. Speed is not absolute. It's relative. It depends on who's measuring. If you're in a car going 100 kilometers per hour and I'm standing on the road, you're moving at 100 kilometers per hour from my perspective. But from your perspective, you're sitting still. The world outside is moving. There is no true speed. Only speed relative to something else. Except for light. Light always moves at the same speed. Always. No matter who measures it, no matter how fast you're going. You could be standing still. Light zooms past you at 299,792,458 meters per second. You could be in a rocket going 99% the speed of light. Light still zooms past you at 299,792,458 meters per second. Not 1% faster, the full speed. Your brain is screaming, that's impossible right now. And you're right. It is impossible, unless something else is changing. Einstein figured this out in 1905, and it broke physics forever. If light always goes the same speed for everyone, then time has to be flexible. I know, sounds like science fiction, but stay with me because this is real. And Feynman loved explaining this. Imagine you're on a train. You throw a ball straight up. It goes up, comes down, lands in your hand. Simple. But what if I'm standing outside, watching you through the window? From my perspective, that ball doesn't go straight up and down. It goes up and forward and down. It travels in an arc, a longer path. Same ball, two different distances traveled, but both perspectives are correct. Now replace the ball with light. You shine a flashlight up while you're on that train. The light goes up, hits a mirror, comes back down. From your perspective, it traveled a short distance. But from my perspective outside, the light traveled a longer path because the train was moving. Same light, two different distances. But light has to go the same speed for both of us. So if distance is different and speed is the same, what has to change? Time. Time itself has to slow down for you on the train compared to me standing still. This isn't theory. This is measured, proven, real. Astronauts on the International Space Station age slower than people on Earth, by microseconds. But it's measurable. GPS satellites have to account for time dilation, or your maps would be wrong by kilometers. Time is not the same for everyone. And this is because of light speed. That one number, 299,792,458 meters per second. But we still haven't answered why. Why that number? Feynman's answer is coming, and it's going to blow your mind. Okay, remember that weird number I mentioned earlier, 1/137? This number haunted Feynman his entire life. He called it a magic number that comes to us with no understanding. Here's what it is. It's called the fine structure constant, represented by the Greek letter alpha, and it shows up everywhere in physics. Quantum mechanics, electromagnetism, the strength of forces between particles. But here's the crazy part. It has no units. It's just a pure number, 1 divided by 137, and nobody knows why. Remember when I said light speed is connected to 1/137? Here's how. The speed of light, that giant number, 299,792,458 meters per second, it's not fundamental. It's derived. What's fundamental is the fine structure constant, 1/137. The speed of light is just what happens when you combine that constant with other properties of space and electromagnetism. Feynman realized this, and it drove him crazy. Because we can measure 1/137 to incredible precision, but we have no idea why it's that value. Why not 1/100? Why not 1/200? Why 137? And here's what Feynman said about it. It's one of the greatest damn mysteries of physics, a magic number that comes to us with no understanding by man. You might say the hand of God wrote that number, and we don't know how he pushed his pencil. If that number were even slightly different, you wouldn't exist. Okay. Here's where this gets really wild. Scientists have done simulations, computer models. What would happen if we changed that number? If instead of 1/137, it was 1/130, or 1/150? And the answer is terrifying. If the fine structure constant were just 4% different, atoms wouldn't be stable. Chemistry wouldn't work. Stars couldn't form. The universe would be dead. If it were too big, electrons would spiral into the nucleus. No atoms, no molecules, no you. If it were too small, electrons would fly away. No chemical bonds, no matter as we know it. The number has to be exactly in a tiny range around 1/137 for anything to exist. And nobody knows why it landed on that value. Feynman spent decades trying to figure it out. He filled notebooks, chalkboards. He obsessed over it, and he never found the answer. But here's what he did find, and this is the part that will change how you see everything. The speed of light isn't a speed limit. It's something else entirely. All right, deep breath, because this is it. Feynman realized something that nobody else saw. The speed of light, it's not about light. Light just happens to travel at that speed because photons have no mass. They're massless, so they go as fast as the universe allows. But the real limit? It's not a speed limit at all. It's the speed of causality. Let me explain. Cause and effect. You push a button, a light turns on. You throw a ball, it moves. Cause, then effect. But cause and effect can't happen instantly across space. Information has to travel, and information has a maximum speed. That speed is what we call the speed of light. It's the speed at which reality updates itself. Think about it like this. The universe is like a computer simulation, and it has a frame rate, a refresh rate. The speed of light is how fast the universe processes changes. We live in a universe that updates at 299,792,458 meters per second. That's how fast reality can propagate. That's how fast cause can create effect. And that's why nothing can go faster, because faster than that doesn't exist in the structure of space-time. Feynman saw this, and it changed everything. The speed isn't about light at all. Light is just the messenger, showing us the fundamental speed limit of reality itself. And the fine structure constant? That magic number 1/137? It determines how strong the electromagnetic force is, how tightly matter holds together, how reality itself is structured. We don't know why it's 1/137, but we know that if it weren't, we wouldn't be here asking the question. You exist because that number is what it is, and nobody knows why. So, here's where we are. Feynman asked a simple question. Why that speed? And the answer led him to one of the deepest mysteries in all of physics. The speed of light isn't random. It's derived from a pure number, 1/137, the fine structure constant. That number determines the strength of electromagnetism, the stability of atoms, the structure of reality. If it were even slightly different, nothing would exist. And we have no idea why it has the value it does. Feynman called it a mystery written by the hand of God. And he meant it. He died not knowing the answer. But here's what he did know. And this is beautiful. The universe didn't have to be this way. The speed of light could have been anything. The fine structure constant could have been anything. But it's not. It's exactly what it needs to be for stars to shine, for atoms to bond, for chemistry to work, for life to exist, for you to be here, right now, watching this video, thinking these thoughts. You're not just in a universe with these numbers. You are these numbers. Your atoms, your molecules, your DNA. All of it is held together by forces that depend on 1/137. You exist because the universe picked that number, and Feynman spent his whole life trying to figure out why. Maybe someday someone will. But until then, we live in a universe with a mystery at its heart. A number we can measure but can't explain. A speed we can calculate but can't understand. And honestly, that's what makes it beautiful. If this changed how you see reality, hit that like button, subscribe, turn on notifications, because we're just getting started. The universe has 1,000 more mysteries like this one, and we're going to uncover every single one. See you in the next video.